Hello, my name is Yotam Golan. I am a fourth year computer science and economics major at the University of California, Santa Cruz. This was my first summer working with Cross, and I got to be mentored under Akil Dixit, who created CAvSAT, the project which I helped work on. My main task while working at CAvSAT was creating a synthetic database generator to help test it. This generator would serve to supplement existing real-world databases by allowing for a specific schema that would otherwise be hard to find. So what is CAvSAT? CAvSAT is a tool being developed by Akil that aims to serve as a scalable and comprehensive consistent query answering system. CAvSAT transforms queries into variants of Boolean satisfiability and then uses SAT solvers to compute consistent answers for the query. Now, the challenge of working with testing CAvSAT is that CAvSAT is still under development, and this means that finding databases to test on is an important step. Real-world databases are, of course, preferable, but present several important issues, namely, finding available databases that possess the specific constraints and inconsistencies that the tester wants is time-consuming and can be difficult. And even when that database is found, understanding the integrity constraints and its general schema can also be difficult and time-consuming. These two factors mean that there's a niche available in testing for synthetic databases. This is where my work came in. While working for CAvSAT, I developed a synthetic data generator, one that allows the tester to specify its schema, integrity constraints, size, and inconsistencies. And this is so the tester can work on databases that would otherwise be very difficult to find or to use. This is useful to supplement real-world databases and allow for more diverse testing of CAvSAT simply because a synthetic database has more fine-tunable parameters than a real-world one. This is the general flow of my generator. It flows very linearly. First, the main, which takes the given parameters from the tester. These are the database connection, the schema of the database to be generated, the SQL query to be answered, the size of the database to generate, and how much inconsistencies to generate as part of it. Hash maps are then generated. These serve to both ensure that all the tuple attributes of the same pool can cross over with one another to make the data more interesting, but also make sure the key constraints are respected. Two tuples will not share a key unless I want them to. Generate consistent creates the tuples that follow the given schema. Each generated tuple is unique and has no key overlap and follows all integrity constraints. Generate inconsistent, on the other hand, creates tuples that purposefully violate the schema. The tuples are unique, but the keys are shared between tuples, and integrity constraints only sometimes respected. This makes a much wider gamut of possible inconsistencies that makes it more interesting for testing purposes. These functions both then flush to the database and write to it. Generate witness runs independently of main and can be called by the tester separately to create witness tuples for the query. Of these, some will be consistent and some will be inconsistent. This also increases the variety of errors and makes it more interesting for testing purposes, and is used to enrich the database if it just didn't generate enough witnesses for the query. What this all means is that a tester can create an unusual database to match their specific need without needing to find a real-world database that matches the schema or constraint, which, as I said before, can be both difficult and time-consuming. This makes testing of different aspects of CAvSAT easier and faster by allowing for refinement in places publicly available data may simply lack the dimensions needed for. It is, after all, difficult to find a 600,000 long data set with 1,000 attributes. The time following the completion of my generator was spent finding real databases of sufficient complexity so as to be interesting for testing, then taking them and finding the integrity constraints, attributes, and other aspects needed to be useful for CAvSAT testing. If you'd want to see the code, this is the link to CAvSAT, and my code is part of it. Thank you for watching my presentation, and I hope you have a wonderful rest of your symposium.